Morning, doctor. I'm Navin Balan. My metric card number is 2112911019 and my program is RY31 Industrial Power. So today I would like to present about the lab 1 module, that is harmonic and total harmonic distortions based on a firing angles and SCR. So from here I will need to achieve the objective to analyze the harmonic waveforms of the AC voltage controller and to evaluate the THD and harmonic based firing angle. So the circuit should be built is this, a single phase full wave AC voltage controller as known as biometrical controller. Okay, so based on this, constructed that PCM by using the PCM software. So these are the circuit that I have already built. So the voltage I already give us the 230 VRMS. So I change it to the voltage is around 325.27. The frequency is same as 50 Hertz, and the thyristor diode is for zero angles, and one is for the positive and one for the negative thyristors. So and the current and the voltage for the resistor and inductance that need to be calculated. I out VRMS and V out RMS. So the resistor is 50 ohm and the inductance is 100 with 100 milli. So from here I will simulate the answer. I will get this. So from I out and V out. So for the zero angle, so it will be as start from the zero because I already set as a zero firing angle. So these are the results. Okay, and then it goes for the VRMS. For the maximum value, I will from over here, and the RMS value also can be get over here. So for the zero angle. Okay, I already insert the value IRMS and VRMS. The THD is 100% and PFI 1% for the 1 is for the zero angle. And for the 45, 90, 135 and 175 are already drawn in the below. So the angle will be like after 45 it will be triggered for the first part. And then it will be going for the third. Once it's already spiked for the power sub, the once the current is increased, it will trigger to the maximum and it will be slightly reduced when it going to shut down. For same as for the following angles until 100, 0 or 45, and then 90, 135 and 125. So the waveform of the TT is already mentioned for the THD and the firing angle, the power factor and firing angle. At the same time, I already completed the THD and the power factor graph. So from here, the harmonic in the power quality is significant constant in the power equipments, and the frequency in the alternative current power system that are essential to the complete multiple of the fundamental frequencies are referred as the harmonic sounds. At the same time, the basic frequency of the power system is either 50 Hz or 60 Hz, but I already used that 50 Hz on the above. At the same time, the nonlinear loads have effects on evidence of the current waveform harmonics, the currents, and the potential to the occur. And it is a qualify harmonics. It is necessary to monitor and assess the power quality. As a result, the voltage will be increased losses, resonance, and the breakdowns of the equipment. Nonlinear loads can be assisted in the maintaining a high level of power quality and minimizing the adverse impacts on harmonics have electrical systems. So this system, this experimental of TDH and PF and firing angle are distributed from the graph following and complete the experimental that I already done, which is based on the data that point is fed objective and experimental has been accomplished. To summarize, harmonic has a substantial impact on electrical systems that have effects on the quality of a transmission. There are possible of harmonic components to correspond with the natural frequencies could be results in a high current and voltage which could result in a failure of equipment's limited lifespans of the spikes. So the absolute necessary to complete the requirements and guidelines of harmonic control in order to achieve the power quality level that are above accepted limits. It comes to identify the address of harmonic and monitoring and analyzing the power qualities and absolute necessary. Thank you, madam. So these are the things that I already mentioned. So I think that's all from me. Thank you.